Good morning. My name is Dick Miller. I'm a volunteer docent at the Marchfield Air Museum, and I talk about airplanes periodically, and other times I'll take people around in the tram and talk about the airplane. So if you get this, come out and visit us because we'd like to see everybody out here. It's a great museum. This morning we're going to talk about the C-47 or the VC-47. The 47s were derived from the DC-3s, which were derived from the DC-1s and DC-2s. They started producing the C-47s in 1935, and they celebrated their 75th year in 2010, so it's been around for quite a while. It was used in all theaters of the war, through the war, and also in World War II, and used in Korea. And then, of course, it was used in Vietnam as a gunship. So it's been around for very many years, and now they're flying commercially. I watched a documentary the other day on TV about Buffalo Air, which runs out of northwest Canada, and they still fly the Goonie birds with passengers and sled dogs and cargo and all that stuff all over Canada and into Alaska. So used still very, very much in commercial circles. The C-47 that we have here is a VC-47A, which is used to haul people around with VIPs and so forth. And in fact, that airplane was flown by the California Air Guard for several years, flying the governors of California, the Browns and Reagan and so forth. This particular aircraft was built in 1944, went into the Air Transport Command, ATC, taken over by the California Air Guard later on, and then eventually retired around in the 1960s. The Goonie bird, as it was called in the Air Force, was one of our great aircraft. It was one of the four operating systems or combat systems in World War II, as testified to by General Eisenhower, former President Eisenhower. And he mentioned the Goonie bird, the atom bomb, the tank, and the bazooka as some of the greatest weapons in World War II. As I mentioned, they were used in all theaters of the war, and they were used for just about everything. They were used to carry people. They had 28 bucket seats inside for carrying troops, paratroopers. They removed a tail cone and put a hook in the rear to pull gliders, and then they were also set up to carry 18 wounded. They had 18 litters that they could set up in the rear of the aircraft. Crew-wise, they had pilot and co-pilot, sometimes a navigator, always a crew chief, and sometimes a radio operator. So minimum crew, just a great aircraft. What we'll do first here today is, after the introduction we talked about a few minutes ago, we'll start walking around the aircraft, pointing out a few of the old parts of the aircraft that are fairly interesting, we hope, and then we'll end up going in the inside and talking about the instrument panels and how the inside was set up previous to this. As you notice, we have, it's a twin-engine aircraft. It cantilevered wings, has retractable gear. The engines are Pratt & Whitney 1830s, 1,200 horsepower each. That's my my New England accent coming in. But and then they had Hamilton standard full feathering propellers. You see below the nose is front end is kind of a funny looking thing. It's an antenna, radio antenna. Then there's a directional antenna for the ADF underneath the nose. Then you see those two tubes coming down. They were the pitot tubes. They were used to get ram air in, and they compare that with ambient air inside the cockpit, so you get an airspeed reading on your airspeed indicator. If you notice, it's conventional gear. It's not a tricycle gear. It has a tail dragger, tail wheel in the back, and two, of course, main gears. Also, you notice on the side is an intake for a turbocharger, and then, of course, up on top is another air intake, and then around the engine itself, those little doors or little panels that you see around there are called cowl flaps. and they can be opened and closed by the pilot or the co-pilot, and they also can be put into a trail position, just operating by themselves, airflow through the engine. Their job was to allow air to come into the front end of the engine and cool off the cylinders. And as I said, they were controlled by the pilot, or they could be put on trails so they'd operate by themselves. Also, on the wing here, you see there are de-icer boots, and there's a landing light there, and you see the little shield on it so that it doesn't bother the pilots. That landing light on this side, one on the other side, of course. The de-icer boots were common way back when, before they started heating the leading edge surfaces. Back then they used compressed air, and they would pump air in underneath the tubes in the de-icer boots, and it would alternately deflate and inflate and crack the ice off of the leading edge of the wing if they were in icing conditions. In addition to that, the propellers were anti-iced with isopropyl alcohol, and this one here, I can't see it on this one, but on the if there were, normally there's a heavyweight panel where that red line is, and that's when the propeller threw off ice. It would hit that heavier panel and not damage the side of the aircraft. We can start walking around a little bit now, and regular cantilevered wing, very large wing, but very heavy lift wing. And you notice on this aircraft here that it does have windows along the side, because it was an aircraft that transported people around, and as I mentioned, it did transport the governors of California for several years. The tail wheel that you see in the back is can be locked or unlocked depending on what you're doing. Takeoff, it would be locked. Taxiing around, it would be unlocked so that you could maneuver the aircraft, either with the engines or the brakes and so forth. When the aircraft were used in Vietnam as spooky gunships, or they were called Puff, the Magic Dragon, and of course corrupted by Air Force crews to Puff the Tragic Wagon, and that's where they cut holes in this side of the aircraft, left side of the aircraft, and put 3 7.62 millimeter Gatling guns in there, and that's what they used in the spooky gunships to support the troops on the ground. Also might mention the C-47s had double doors, clamshell doors in the back, so that they could actually load a Jeep in it and carry a Jeep into combat or whatever they wanted to use. And in the old days, these were fabric, but they're metal here. Normally the control surfaces in the old days were fabric, but now these are metal. Notice there's wing locks, elevator locks that the pilot definitely wants to remove before he flies. And just continuing around, you notice that the leading edge of the tail and the elevators are also this type of ducting work, or anti-icing, de-icing. I mentioned before, you see California Air Guard on the aircraft. Also, you see on this one here an aileron lock. These were put on when they were stored overnight or whatever, to keep the wind from flapping these things and damaging them. You could lock here, and then some aircraft have control locks in the inside to lock the wheel and rudder pedals, but this one here had control surface locks on the exterior. Continuing around, right aileron, notice there's a trim tab, that little tab there. What that was is a tab that controllable by the pilots, and what that does is, if when you want the aircraft to fly straight and level, you have a trim tab on the tail, you have trim tabs on on the ailerons that you can adjust, and on the elevators also that you can adjust to make the aircraft fly straight and level on accelerated flight in a cruise situation, actually to get the most efficient use of the aircraft. It's pretty much the same as the left side, of course. One thing I want to do now is to invite anybody who watches this to come out to the Marchfield Museum, because we do have 70 to 80 aircraft out here, and we do have tours where we talk about all of the aircraft. So if you'd like to learn more about this aircraft and other aircraft, come on out and visit us anytime. We're open 6 days a week, closed Mondays and from 9 till 4 in the afternoon. The engines were 14 cylinders. They had two banks. They were called twin Wasps engines because of the two banks. And they had 7 engines per bank, so they had 14 cylinders total. And they developed 1,200 horsepower per engine, so you had 2,400 horsepower available in the aircraft. They could fly single engine, not fully loaded. I never had any chance to do that, but you could fly a single engine with it and still maintain flight conditions. Under the wing, drains. You have drains for tanks down here, and various inspection plates. As you can see, this is all riveted construction. They're not flush rivets, they're rounded rivets. And later model aircraft, they flush riveted, which means that there's no bumps. They're just flat on top, and for better airflow and so forth. You notice they have de-icing areas on the props. Of course, they had prop anti-icing where they ran isopropyl alcohol out. I don't know if this is strictly electric. It could be an electric panel there that would, through heat, de-ice the props. But they normally had isopropyl alcohol with little tubes coming out of the top up there. Well, you see a little tube now where isopropyl alcohol would come down and melt the ice. That pretty much takes the airplane here, the exterior. And mentioned the C-47 were produced in 1935, and they built over 10,000 C-47s. DC-3s, they built about 300 of those, and those were the aircraft that were used by American and United Airlines in the early days in the 30s. They were called Skytrains back then. And when they started manufacturing the C-47s, they kept on manufacturing 10,000 of them they used in World War II and later. The Japanese also stole the plans. They made some of them. The Russians did the same thing, and they made C-47s. And pretty much every nation in the world either manufactured or flew C-47s. It was such an excellent aircraft. This is the entry stairwell for VIP passengers. In a normal DC-3 or C-47, they had a very, very narrow little ladder with a couple of steps that hooked into little openings there that you walked into. But this is pretty plush compared to the C-47. But this is a BC, as I mentioned. And we'll start up the stairs. On the right side back here, they had a restroom, latrine, whatever you want to call it. They also had hang-up rack for clothing and storage areas on this side and a work area over here. And as I mentioned, these were pretty plush compared to the old C-47s that the military used. Now as we walk into the interior, The one I'm familiar with, we had bucket seats lining both sides, and they had depressions where the chutes would fit in, and there was 28 of them, and 14 on each side, and they could also put litters here to carry wounded, and they could rig 18 litters, 9 on each side if they were carrying wounded. They also, in the C-47s in the floor, they put tie downs where they carried cargo. They could tie the cargo down in the interior. Could carry 6,000 pounds of cargo, by the way. The maximum gross weight of the aircraft in flight was 26,000 pounds. So, you notice this one here too, it has lights on the side for the passengers. There'd be seats here on the side. But in the also, they had heaters along the floor that you can see. In the C-47s, they had a large compartment that went on the ceiling of the aircraft down through, and they had round vents in them where the heat would come in and theoretically go down. But you know heat doesn't go down. Heat. So what we had to do was put cloth tubes around them so that they were just above the floor. They would run heat down to the floor so you wouldn't freeze to death in the back seat of the suit. Okay, we're going to start proceeding up here. One thing about a C-47 and the DC-3s and so forth is the fact that they are in this attitude on the ground. You also always have to climb uphill to the compartment up ahead here. There's a door here on the right. In flight, if you weren't carrying passengers, if you wanted to keep warm up front, you close this door and the heat would remain up in front, and also if it was really cold, you'd do that to keep the heat up front. The guys in the back would more or less have to shift for themselves, but anyhow, that was one thing that happened in this aircraft. On the right here, in back of this door, is the radio operator's position. His radios would be fitting in these racks here. He had oxygen equipment back here, of course, lighting and whatever that he needed. Control boxes for his radios. And as I say, this is where the radio operator's position was. As I mentioned, this is a VC, so they had heating facilities for heating food. They had, this one here is a heater, or a cooler actually, or I guess, no, this was a heater this was for heating food, and preparation area here. And so it was a pretty plush old bird when it was flying. That's all part of it. In some of the aircraft I mentioned, the earlier, not the BC, but the regular C-47s, they had a position for the navigator, much like the radio operator back there, and he was on the right side, on the actual left side of the aircraft here, and that's where the navigator would sit. Oxygen cylinders, fire extinguishers, lights, pocket lights, another fire extinguisher. This side here, as I say, had various hydraulic systems, parts of hydraulic systems here. These are your selector valve for the left or right engine hydraulic system, and this is your flaps and your landing gear handles down here. And I'm not going to fool around with those because I don't have any idea what's connected or not connected. It might bleed off and gear would be cracked, so we're not going to fool around those at all. Okay. We can go up into the cockpit now, and see if we can get into the seats without killing ourselves. I was a little more agile when I was back flying these. I guess we could start over here. This is the radio control for switching to call position, to talk outside intercom for inside, and also a place back here that's your oxygen regulator on the back here that regulates your oxygen. It mixes it with air, of course, and you breathe. You could breathe either pure oxygen or diluted oxygen. There's one over on that side also for the co-pilot. And of course, control wheel. You can open these up, slide the windows back. This was very interesting aircraft. From the viewpoint of it took, at least in weather, say you were in icing, it would take at least 3 people to keep busy in flying this aircraft and keeping it airborne, especially if you're flying instrument approaches. I flew single engine jets for years, and there was a lot less to do in those than there were in this one here. For example, to de-ice the windscreen, okay, you had to run the little tubes here. You'd run isopropyl alcohol on the windscreen, and then you'd turn the windshield wipers on. They had windshield wiper controls on each side. In addition to that, it had, okay, where are they? Cowl flap controls over here on that side, the yellow handles. That controls those doors I was talking about on the front of the engine, where it controlled the air going through the engine to cool the cylinders, and you could put them in trail if you wanted to, just let it automatically open and close depending on the temperature of the cylinders and the engine itself. As far as the control surfaces are concerned, or the controls are concerned, this is the autopilot control. You had a heading control, altitude control, roll control, all kinds of things to be able to fly the aircraft. And this is altitude return, okay. Huh. This is a very basic autopilot. This is an elevator trim. Remember those little control surfaces I showed you on the elevator back there? Those move those up and down to maintain level of flight. Controls for the engine. You had the props, propeller control, you had the throttles, and you had the mixture. You notice the mixture has a lock on it, so theoretically you weren't supposed to be able to pull these back without unlocking the lock. The reason for that is you didn't want to shut the fuel off going into the engine inadvertently. Another little story, maybe it's not particularly family-friendly conversation, but you've heard the expression maybe balls to the wall, okay? Well, back in the old days, these are balls. You can see there are balls. And balls to the wall meant everything was forward. And that was an emergency condition where you wanted full power, max switch, and throttles all the way up, prop full increase, to get you out of a position that a dangerous position that the aircraft was in, and so forth. Ouch. Panel lights, control panel for the VHF radio. This is a VOR, very high frequency omni range. This is an HF transmitter, that was high frequency transmitter, that was another radio. This was the radio compass. And this over here, this is an ADF number, the second radio compass. That used that funny looking antenna underneath, that kind of a teardrop antenna to work it. Over your head you had a blinker to tell you if oxygen was flowing. When you breathe in and out, the blinker would go. This would give you your oxygen pressure. And of course a warning light if something happened. You also had an opening which you can open up over the top if you crashed and you wanted to get out of the aircraft. You can get up over the top and get out that way. Electrical control panel along here, landing lights. What's this here? This is inverter light. And cockpit. Okay. These were feathering buttons. If you had problems with an engine, you wanted to what they call feather the prop. If you turn the blades parallel with the wind, this was your feathering button. You could push it in and push it out to unfeather it. And that allowed the aircraft to fly more aerodynamically pure without the props against the airflow, which would cut down your speed and require more power. More electrical panel instruments along here. And let me see. Notice up here it does say emergency exit if you had to play it out at the top. Okay. Going down to the panel down here, pretty standard round dial instruments. You had a magnetic compass here, and you could, well, you can't move it now, but you could set your regular compass, gyro control compass, off of the mag compass, getting you the correct headings. Okay, this is an autopilot controls here. This is an artificial horizon, another artificial horizon here. This is for the autopilot, by the way. And you had this is an ID 249. Gives you fore and aft and horizontal crosshairs for flying instrument landing system approaches. This is the glide slope. This is the glide slope here for the two radios, if you had two of them. This is your vertical gyro here. And this is your ID 250, number 1 needle pointed to the VHF station, low frequency station, or radio compass station, and our commercial radio station. And this one here pointed towards the very high frequency omni-range station, the number 2 needle. The airspeed indicator. These are kind of strange instruments. Of course, this is your altimeter. I can't read that one on here. Some of these instruments you can't read. This is vertical velocity, and this is rate of climb down here. And this is your manifold pressure gauge for the 1 and 2 engines, and the tachometer for the 1 and 2 engines, oil pressure for the 1 and 2 engines, and the fuel pressure for the 1 and 2 engines. Pretty much duplicated on the other side, on the co-pilot's side. Had some warning lights there, fire warning lights, and green light for well, could be gear up in the green. And they had regular free air temperature gauge here, and that autopilot control is over there. Fuel quantity gauge here, and actually pretty well instrumented for an older aircraft. On the right side over there you had landing gear pressure, and then hydraulic system pressure gauge there. So, and to raise and lower the gear, you had this was a here that would lock the controls where they were, and this is a hand pump where you could actually pump hydraulic pressure into the gear cylinders, flap cylinders. And then back here you had, I don't know if you can see this ball, but you had your engine selector, which would tell you which engine you were pulling the hydraulic pressure off. And then you had a control to turn it on, turn the hydraulic pressure on, and this is your flap valve that control your flaps, and this, of course, your landing gear handle down here. So pretty much standard stuff. It was a fairly easy aircraft to fly. It was a tail dragger, as I mentioned, outside, and so you had to be familiar with tail dragger versus tricycle gear idiosyncrasies. And it was a lot easier to fly a tricycle gear with nose wheel steering and so forth than it was to fly one of these with a tail wheel where you had to actually use brakes for steering and so forth, or engine controls to run it up. Okay. Flying, flaps on takeoff. When I flew these out of O'Hare in Chicago, we had 10,000 foot runways there, so there wasn't really much of a problem in getting it off the ground. They had two 10,000 foot runways at least back then in the 50s and 60s. Of course, they have much longer now, I'm sure. But prop control the RPM, full max RPM takeoff, throttles takeoff, mixture rich on takeoff. When you broke ground, you could normally have settings where you bring the manifold pressure back to a reading, and with the throttles, and then the prop control, you could control the speed of the prop, and then you'd lean the mixture out so that you wouldn't load up the cylinders. Should be a control down here for, okay, here's your fuel supply on both sides right here. And what else we got down here? That's our, actually the rudder trim, the little control door on the not on the elevator, on the vertical fin. This would control the direction. You want to even it out and keep the ball centered on directional control. Interesting things down here. I'd say it was a very interesting aircraft to fly, and in weather, say you were making an instrument approach like we used to have to into O'Hare with this aircraft, and if you had icing, okay, you had cowl flaps to worry about, you had de-icer boots to worry about, you had prop de-icers to worry about, and it kept three people busy. The first pilot, of course, flying the approach, the co-pilot on this side lowering and raising the flaps and the gear, and it kept three people busy in weather in this aircraft, where in aircraft I'm familiar with, jet aircraft, to go for, so for a lot of that is automatic and takes care of itself. They're much easier to fly, in my opinion. You have one throttle, and that's it. And this one here, look at all the craziness you have here. You wouldn't have any of this here. All you'd have is throttles. And it just was an interesting aircraft to fly because it kept people busy. But it was a very safe aircraft. And as I say, you rolled along at 140 knots, and it was just very comfortable flying it, and good visibility. And so it was a joy to fly. This, by the way, are the mag switches to turn the power to engines, and you'd use these to check your engines prior to takeoff. And this is actually pretty basic, and it kind of like old home week here. Okay, on takeoff, of course, as you're taxiing out, your tail wheel is unlocked so that you can turn the aircraft using engine power either side, and just to control the speed of the engine, and you can turn that way, of course. And other than that, you can use your brakes to turn, and that's what you would do on your way out. As you lined up for takeoff, you would normally have the props full increase, and then you'd come in with the throttles, full throttle, and mixture control should be full rich, okay, for takeoff. If you were operating off of a higher altitude where the air was a little rarer, you'd want to decrease the mixture a little bit to make sure you didn't load up your cylinders. Takeoff, stick back, throttle all the way forward, and as you accelerated, the tail wheel would come off the ground into level flight, and at around 100 knots, 95 to 100 knots, back pressure, take off, and after you broke ground, then you'd get your gear up and flaps up back here, and adjust your throttles and your props for the climb power, and you were on your way. When you leveled off at altitude, you'd adjust the throttles for the RPM or the manifold pressure you wanted, your propellers for the prop speed, and your mixture control, leaning these out so that the engine runs at maximum RPM for the power setting you want. Landing, a very interesting landing at O'Hare, because you could be in a stream of jet aircraft, and they were rolling along at 250 knots, and you were rolling along at 140. So what they would do, the controllers would do, was trying to get you up as close to the aircraft in front as they could without you having problem with jet wash. And normally what we would do is to turn you on to a downwind leg, which is parallel to the runway, going against the way you go to land. And during that period of time, you'd get your gear down, partial flaps, and as you turned base leg, which is 90 degrees to the runway heading, you get your flaps the rest of the way, and then as you turn final, of course, you'd adjust airspeed down the final, normally around 95 or 100 knots to go down the final. While this was all going on, of course, you were running prop de-ice, you were changing frequencies on the radio, you were listening to the tower, and just making sure the aircraft is going to be flying, and you just roll on down the final, watch the instruments, radio instruments, staying on course and on the glide slope if there had one, and if not, just a rate of descent to bring you in, aiming for the end of the runway, and get over the end. Your throttles would be pulled off, set it on in, and you'd then make sure the tail wheel, it was locked for landing, but it was unlocked for taxiing. I forgot to mention, when you took off, you wanted the tail wheel locked so to help you in directional control down the runway. Landing, just and then enough power it takes to get you off the runway and to your parking area. As I said, it's relatively simple flying the approach. It's just making sure that everything is set, cowl flaps and so forth are all set, and you're de-iced, and you're just making sure the aircraft is still flying, and bringing on in for landing. It really wasn't that hard. With a crosswind, use a combination of aileron and rudder to keep straight, landing in a crosswind. And this aircraft was not too bad in a crosswind. You had max crosswind, which was maybe 20 or 25 knots direct cross, but normally there are enough runways so that you'd be running in where a crosswind wasn't too great that it would give you a problem with aircraft control. One interesting experience we had going into O'Hare one day was we had gotten a replacement aircraft. They took away our C-47, and they gave us a VC-47. Well, they wanted to use our first aircraft. They wanted to make a spooky gunship out of it because it was in such good shape, so they just took it away from us and gave us a VC. Okay. Well, what we didn't know, when you brought the throttles back to land, bring your power all the way back, your generators would drop offline. And when they dropped offline, you'd lose your radios. Okay, well, we landed as per normal, throttles all the way back, and as we were rolling, we heard this sound, very loud sound going over the top of us, and looked up, and there goes the 727. Okay, well, we eventually found out we'd forced him to go around, and that's not very good for airliners. So anyway, when we rolling down the runway, fat, dumb, and happy, more or less, brought the throttles in to taxi off and turn off and unlock the tail wheel and so forth, and the taxiing off, and the tower is screaming at us about, why didn't you hear us? Why didn't you hear us? You didn't hear us. What you did was make a 727 full of passengers go around, and it was embarrassing, but nothing we could do about it. They finally, maintenance people, after this happened once, they decided that they would make sure the generators didn't drop offline when you brought your throttles back, so you'd have radios all the way along. And if they told you to get off the runway as soon as you can, of course, we'd take the high-speed taxiways and get off, or a taxiway that we could turn off on. But anyway, it was a little embarrassing to see that 727 going off into the distance full of passengers and us sitting on the runway, still just lazily rolling down. So it's quite an interesting experience. Okay, well, closing off here, I'd like to invite you all that are listening to this to come out to the Marchfield Air Museum. Very interesting. And as I mentioned, we have tram tours where we'll take you around. It takes about half to three-quarters of an hour. We talk about all of the aircraft here. I've flown a lot of them and be able to give you some insider information on the aircraft. And we also have just great exhibits inside. We have a restoration area that you can get into here, and the P-38 National Association's museum is here, which is a free museum that you can get into. But come on out and visit us and see the aircraft, and we're always happy to have you come out because you keep us in business, and you're a great help. Everybody is, and we just appreciate the attitude of people that come out here because they are really interested, and we enjoy talking to them. So thank you, and come out and see us.